Hello, welcome to my talk on writing a Kubernetes operator in Java. My name is Fabian, and what are we going to do in the next 45 minutes? This is a talk without slides, so I will actually write a Kubernetes operator in Java. And the idea is that if you see the code and see what it does and follow along, then you get an understanding of like what operators do in general and how you could do similar things in your own projects. A few words of introduction before we start. So what is an operator actually? I guess you all know what Kubernetes is. So Kubernetes is a runtime environment for Docker containers. And Kubernetes does a lot of things out of the box. So for example, like if you have a Docker image and you decide that you want to have 3 instances running of your Docker image, then you can easily write in Kubernetes a deployment descriptor specifying the number of replicas should be 3. And when a pod dies, Kubernetes will see that and will create another pod for you and make sure that you always have the number of instances 3 running, okay? However, there are applications where this is not enough. And if you read something about operators like introductions, there is one generic example that you often see. And this is like, imagine you have a distributed key value store, right? You might have configured it in a way so that it runs with 3 instances, and all of a sudden an instance dies. So what Kubernetes will do, it will detect that the pod has crashed and start a new pod for you. However, for that specific key value store, this might not be enough. Maybe you need to reconfigure the instances and tell them that one instance left the cluster and another instance joined the cluster. Or maybe you need to trigger a job so that the 2 remaining instances start shifting over data to the new instance, something like that. So there might be application-specific operational tasks that need to be done on top of what Kubernetes does out of the box. And whenever you have something like that, then it might be a good idea to write an operator to operate your application. So an operator is basically, it's a piece of software running in Kubernetes that will run your application. And of course, it will use everything that Kubernetes provides out of the box. But in addition to that, you can implement operational steps that need to be done that Kubernetes doesn't provide, right? So that's an operator in a nutshell. And maybe a few words about me. How do I fit in? So my name is Fabian. I work for Instana. Instana is an APM monitoring company. So we have an APM tool with a focus on monitoring microservice applications or dynamic environments. And of course, Kubernetes is one of the most important platforms we support. And if you want to install our Instana monitoring agent in your Kubernetes cluster, then this here, the Instana agent operator, is one way of doing it. And this part is actually open source. So if you, after the talk, would like to see a little bit of a more complete example, you could just browse the code and see what we did there. And I am like one of the engineers who wrote this thing. Okay? Good. Let's get started with the demo. Let's close this. I am here in an empty directory, and I will start everything from scratch because I think it's better to see like complete examples than just some snippets. The frameworks that I'm going to use is Quercus, this new Java framework by Red Hat, and a library for interacting with the Kubernetes API server, which is the Fabricate Kubernetes Client. Why Quercus? So in case you haven't heard of Quercus, never mind, you can basically think of it something similar to Spring Boot. But if you want to write software that's supposed to run in Kubernetes, it might be worthwhile to have a look at Quarkus, because like what you can do with Quarkus, you can produce an executable jar file. And in that case, it's really pretty similar to what Spring Boot does. But alternatively, you can take your code and compile it to a native executable, like an actual Linux AMD processor 64-bit executable. And the advantage then is that this doesn't need a JVM to run, right? And if your intention is to take your application, put it into a Docker image and ship it to Kubernetes, then if you do it like the classic way and you have your executable jar and you make a Docker image with Java 8 runtime environment in it, etc., then you easily end up with a Docker image that's like much larger than 200 megabytes. And if you want to pull it over the network, everything takes long, and then you need to configure the memory limits for the garbage collector and everything, and it feels a bit unnatural to work with these things in Kubernetes. And if you compile to a native executable, you will end up with something like 20, 30 megabytes, and it doesn't have dependencies, so you can put it into a very minimal Docker image, and it, of course, pulls faster, and it kind of feels a little bit more natural to work with these things. However, in this demo, I'm going to use Quercus, but I will compile to an executable jar. The reason is that compiling to a native executable takes, I don't know, 2 or 3 minutes, and I don't want to wait until the compilation is done, so I'm going this path. So basically everything I'm going to show you, you could do with another framework like Spring Boot or something as well. Right? So let's set up the project. I have, this is a long command line. It's basically copy and paste from, if you go to Quarkus.io, getting started, my first Quarkus project. It's a Maven archetype that you can like copy and paste there. And then it creates an initial Maven project for you. Let's open this. And it's basically a hello world REST service, right? So if we look in source, main, Java, there's something like a greeting resource, right? Let's make it a little bit bigger. Yeah, and if you do an HTTP request to /hello, it responds with hello. So I will ignore this class for the rest of the talk. It's just an easy way to get started and have an initial Quarkus project, okay? If you actually implement your own operator, this might even be useful because typically things that run in Kubernetes have health checks, and you could extend this and transform it into an health check endpoint, but I'm not going to do it. So what I am going to do is, so in the first demo, I simply want to write an operator in quotes because it doesn't really do anything, but it should, if you install it, it should give you a list of pods running in its current namespace, and then it should start watching for events related to pods in that namespace. So whenever a new pod is added or a pod is deleted or a pod changes its status, for example, from container creating to running, then you should get an event so that this operator always has an up-to-date view of the pods in its current namespace, okay? In order to do that, I need a client library to interact with the Kubernetes API server. I'm going to use the Fabricate Kubernetes Client, and of course I could add it to the POM XML as a regular dependency, but with Quarkus things are a little bit different because what you can also do, you can call the, like with Maven, the Quarkus Maven plugin with add extension, and then say, please add the Quarkus Kubernetes Client extension for me. And what it does is actually pretty simple. So it modifies the POM XML and added, where is it? These little lines here, just a new dependency with the Quarkus Kubernetes client. So what's the difference? I mean, why don't we just add the actual Fabricate client as a dependency? So the point is, if you want to compile your application to native code, then there are some things that don't really work related to, I don't know, dynamic class loading and reflection and stuff like this. So it's things that you usually don't do in your business logic anyway, but that frameworks tend to do a lot. And so the Quarkus team just took a whole bunch of popular libraries like, I don't know, Hibernate and stuff like that, and turned them into official like Quarkus extensions. And if you use them instead of the actual dependencies, then chances are good that your program works in native mode. So if you don't put random dependencies in your POM XML, but just things that are Quarkus extensions, you have, yeah, maybe not, but your chances are better that it works in native mode, okay? So apart from that, it's just the same thing as the official Fabricate Kubernetes client. So now that we have the client library, let's start and create a client object in Java. So we create a new class, new Java class, let's call it client producer. So like this, I don't want to add anything. And yeah, so what this thing will do, the client will do, it will, as I said, connect to the API server and request a list of pods in its current namespace. So the first thing we need to figure out what namespace we are running in. So what we want to do, we want to write a Java method. Can you see this actually? Yeah, looks good. Find my current namespace. So and basically, if we compile this to an executable Jar file, put it into a Docker image, ship it to Kubernetes, and run it there, this Java method should figure out that it's running in Kubernetes and what namespace it's running in, and return the namespace as a string. So how can you do something like this? There is a trick, which is basically a magic file that Kubernetes creates for us. So the file name is var run secrets Kubernetes IO service account namespace, and this basically is a text file with just a single string in it with the current namespace, and Kubernetes makes sure that this file exists. And this is like how many things work with related to auto configuration in Kubernetes, that there are just some magic environment variables or magic files that you can use, right? And so everything we need to do is just to read this contents of the file into a string. Of course, there could be an exception, but I have never seen this exception actually. And yeah, and then we have the namespace. And I'm going to use CDI in this demo application. It's not really important, so if you do not like CDI or do not know CDI, you can just ignore it. But with CDI, I'm just going to say produce a singleton and give it a name so that I can use it in as dependency injection. Okay? Good. And now that we have our namespace, it's easy to, again, produce a singleton, our Kubernetes client, make default Kubernetes client, for example. We take the namespace as parameter here, namespace, and we just return new default Kubernetes client in namespace. Okay, so this is basically the boilerplate code that you need to get started, and then and then you can ignore this and start writing your actual business logic. Good. So as I said, the first demo should list and watch pods in the current namespace. So I'm just going to create a new Java class called new Java class. I don't know what name is good. Let's call it the pod lister watcher, okay? And of course, what it will use, it will inject the Kubernetes client that we just created. So I'm calling it default client here, and the reason is that later in the talk, I'm going to show you how to interact with custom resources. And so I'm calling this client. This client interacts with built-in resources like pods. I could do the same thing with deployments or secrets or config maps and whatever built-in resources you have in Kubernetes. And so I'm calling this client to interact with these things, the default client, and then later when we deal with custom resources, I will build a custom resource client that's used to interact with custom resources. So that's why I use this name. So, and what we want to do now is on application startup, we want to list pods. So the first question is, how do we even execute something on application startup? So that's the last piece of CDI. After that, you can ignore this CDI stuff. So on startup, so the trick in CDI is you observe a startup event, okay? And this is basically just a fancy way to say, run this method when the application starts. And now we can just say default client pods list. And what this will do, it will make an HTTP request to the Kubernetes API server, request a pod list for the namespace that we configured the client with, and then get a pod list object as response. And we can turn this pod listing into an actual Java list by saying get items. And this is then simply a list of pods. Like this, okay? And now let's just write it to the standard output so that we can run it and see what it does. So for pod, let's call it resource. In our list, what are we going to print? Found resource. Let's say we print the name. So the name of the pod. That's in get metadata, get name. And then we print something which is called the resource version. That's in resource, get metadata, get resource version. So the name, I think, should be trivial. It's just the name of the pod so that we see which pod it founds. Resource version, I assume that's something that many of you haven't heard of before, but it's important to know about resource versions when you want to write your own operator. So I'm just going to print it now, and later when we run the demo and see what it actually contains, I will get back to it and tell you why this is important. Okay? Good. And now that we have, this basically is like a snapshot, the current list of pods in our namespace. And what we do now is we want to subscribe so that we get notified if anything changes. For example, if a new pod is added, a pod is deleted, or a pod changes its status. So status is, for example, it goes from container creating to running or something. We want to get notified if this happens. So this is also fairly simple. So we just say default client pods watch. And what this will do, it will create a WebSocket connection to the API server and say, I'm going to watch pods in this namespace. And then whenever a pod is added, deleted, or modified, the API server pushes an updated version of the pod resource through this WebSocket connection. And the watch method has a callback as parameter that will be called when this happens so that we are notified. It's called a watcher. It's actually two callbacks. It's event received when we receive an event, and on close. So in event received, we can just print what we received. Received event, or the action is the event. So action is an enum. It's like added, deleted, or modified, right? And then let's just print the same metadata as above. So I'm just copying this here, pasting it down, and so we also print the name and the version of the resource where we received an event. And then on close, that's actually something that there are two cases how on close can be called. I mean, first of all, you might, in your business logic of the operator, just wait for a specific event, and once you received it, you don't need to watch anymore. And in that case, there's an API call where you can just close the connection. And if you do this, on close will be called with parameter null. So null indicating this was an intentional close and you explicitly did it. If this parameter is not null, so if cause is not null, this means there is an exception. So this is an exceptional close, and this might happen either if you have networking problems or if you don't have the permission to watch or anything. So this is actually, this is actually an error where you cannot do much. You cannot really recover from that. And so what you can do, you can print the stack trace so that you get an idea what's actually wrong. And then it's a good idea to call system exit. So system exit obviously just terminates the JVM. And it's always like when you write software that's supposed to run in Kubernetes, it's always a good idea if you come to an error where you cannot recover from to make sure that the JVM terminates. Because what will happen then is, of course, your pod crashes. Kubernetes will see that it crashed, and Kubernetes will schedule a new pod for you. And if this was a temporary error, so just a temporary networking problem, this might even fix it, because then Kubernetes schedules a new pod somewhere else and you're up and running again. And if this is a permanent error, then of course the next pod will crash as well, and then Kubernetes will start a new one, and this will crash as well. And eventually Kubernetes will put your application into a crash backoff loop, and you will see with standard Kubernetes tools that something is really going wrong with this pod. So it's a good idea to make it obvious to the Kubernetes admin to see that this happens. So it's much better than just writing log lines and keeping running. Okay? Good. So I think that's all we need. So we can run the demo now. Clean. Okay. This is a rather long command line that I have here, and let's just go through it step by step. So the first is just like in any other Java project, we clean and package, skipping the tests, of course. And this will produce an executable jar file in our target folder, just like with Spring Boot or whatever other framework. There is an alternative profile in the POM XML that you could use to create native images, but we are not going to use it right now. So, and then when we have our executable jar file, what we want to do is we want to create a Docker image with this jar file in it so that we can ship it to Kubernetes. So we call Docker build, and fortunately, our example project already contains a Docker file. So we can have a look at that. It's in source main Docker, dockerfile.jvm. That's what we need. Unfortunately, there's something missing, which I need to add, because what our application will do, it will create an HTTPS connection to the API server. And in order to create an HTTPS connection, Java needs to find an SSL library on the operating system. And this Docker image is very, very minimal, so based on some Alpine whatever thing, and it doesn't have an SSL library by default. So I'm just going to say run apk add NSS. So NSS is an SSL library package for Alpine Linux. And I'm just installing it, and then it's there, and then everything's fine. That's actually a similar thing if you take the other Docker file, dockerfile.native, there's also something missing. It's called libsunec.so. So this ships as part of the GraalVM distribution, and you need to copy it into your Docker image and set a path. So it's in both ways, you have some little thing that you need to fix in the Docker files, and then everything works. Good. And then the last command in my long thing here is called kind load Docker image. So let's run it. And if you haven't heard of kind, so I have a Kubernetes cluster running on this laptop here, and I set this cluster up with kind, and kind is a really good tool. So if you do Kubernetes development and don't know it, I really recommend looking into it. It's kind of an alternative to Minikube, but it's much more lightweight because you don't need VirtualBox or anything. It just works with Docker containers, and it's much easier to set up multi-node Kubernetes clusters. And this command, kind load Docker image, basically takes the Docker image that we just built and copies it into my virtual Kubernetes cluster that I have running on this machine. Okay? Good. So now we are ready. We have a Docker image available called Instana demo operator in version 1. Before we deploy it, what it will do, of course, it will initially list pods. So it might be a good idea to have some pods running so that we actually see something. And I think everyone who regularly works with Kubernetes have their favorite Docker image that you use when you just want to have a pod running and you don't care what it is, just something running. And I always use Nginx for that. So I'm going to run kubectl run image is Nginx, so just the plain Nginx Docker image from Docker Hub. Restart never tells Kubernetes it should just be a pod, no replica set, and no, like if it crashes, it's gone. It's just really a simple pod, and I give it a name, Nginx 1. Okay? So now I have a pod running. I can add a few more, 2, 3. So now I have 3 pods running on the system. And now we can deploy our application. So kubectl apply. I have a small YAML file, demo operator YAML. So what this contains, of course, is a deployment for deploying this Docker image that we just created with replication factor 1. So I just have 1 instance. It does a little bit more, and the reason is if you deploy a pod in Kubernetes, the pod will not be able by default to list and watch other pods in its namespace. There are security restrictions that prevent that. So in order to run it, I created a cluster role allowing list and watch operations for pods, and then I created a service account and a cluster role binding and started this deployment in this cluster role. It's nothing special. If you just read the role-based access control documentation of Kubernetes, you will easily see what you need to do here, but just if you don't do it, you will get errors because you cannot list or watch. Good. Let's look at the logs now. kubectl log -f of my new operator, and it worked. We see some messages. Found resource name Nginx 1, 2, 3, and it found a 4th pod, which is actually itself. It found itself in its own namespace, which is kind of, yeah, sounds reasonable. And yeah, let's simulate some events. So in the other window down here, I'm just going to say edit pod Nginx 1. So if we wait for events, so usually what we are interested in if a pod is like changes from container creating to running, so because then we know it's actually there. But in order to play with something now, I'm going to change something more simple. So each Kubernetes resource has labels, which is kind of arbitrary key value pairs. I'm just going to add a new label, Java Zone Awesome, to my pod Nginx 1, and as soon as I store it, we receive a modified event. Okay, and if I down here say kubectl delete pod Nginx 1, Then I get a few modified events because it changes its status a few times before it's eventually deleted. And then as the last thing, I get a deleted event down here. Cool. So let's get back to this resource version thing. That's the last thing I didn't talk about. So if you look carefully, you might wonder, what on application startup, we found that pod nginx 1 is already running, and later we received the edit event for pod nginx 1. So why is that? How do we receive an edit event for something that's already there? And the reason is Kubernetes keeps a cache of events that happened in the cluster. Right? And as soon as you start watching, you immediately receive all events that are still in the cache. I think it's 5 minutes or longer or something like that, okay? And so what you get is basically you get some events from the past. And this is actually a good thing, because if the underlying library, for example, detects that the WebSocket connection has problems, it could close the WebSocket connection, just reconnect, and if you have a short time interval where you were offline, you will not miss events, because as soon as you reconnect, you will just get all the events from the cache. And it also prevents, it makes coding easier, because if you look at this lister watcher, you see that up here we do a list operation, down here we do a watch operation. But you might think if something happens right in the middle, like after we listed and before we watched, maybe we could miss that or something, but we don't miss it. So as soon as we start watching, we get all events from the last 5 minutes anyway, so there's no race condition or risk of losing something in this code. The downside, of course, is that you might receive events twice, if you, the underlying library, for example, reconnects the WebSocket connection. And that's where the resource version comes in. So when we initially saw pod nginx 1, we saw it in version 4036. And then when we received the edit event for nginx 1, we again saw version 4036. So basically, we know that we have seen this already and we can ignore it, right? And then later, when we receive the next modified event, it's 4246. So this is a higher version. So this is actually something new. And if you build a real list and watch operation, what you do is you create something like a resource cache where you store all the resources that you have observed. And when an event comes in, the first thing you do is you compare this resource version and check if it's older or the same as something that you've already seen. And if so, you just discard it, okay? You don't need to care because you have seen this already. And only if this version is newer, you can update your cache and then trigger the business logic to do whatever you want to do when this event happens. So it's pretty simple to implement such a cache, okay? Just a few lines of code. But you should do it, otherwise you handle events for stuff that's no longer the current state. Good. So where are we? I think we have so far seen a lot of the building blocks that you need. I mean, even if it's not much code, but we know how to figure out what namespace we are running in. We know how to interact with the API server, how to list and watch resources, how to deal with resource versions. There's one big thing missing, and I'm going to focus on this for the rest of the talk, which is custom resources. So what is a custom resource? Let's just open an example. Custom resource YAML. So we all know built-in resources are the things like pods or deployments or whatever config maps that come with Kubernetes. But just the same way as you can apply built-in resources to Kubernetes, you can create your own kinds of custom resource and apply them. So I have an example here. I gave it an API version, instana.com v1 alpha 1. The kind I called demo. So kind is usually something like pod or deployment or something, and I just invented a new kind called demo. Then we have metadata here, and this is basically the same metadata as for any other resource. And it has a name here. As soon as I apply this to Kubernetes, the API server will add a resource version there, so that resource versions works the same way as with what we have seen. And then there is a spec, and the spec is basically arbitrary YAML, okay? You can put whatever you like there. And what real-world operators do, or what the typical mode of operation is, if we come back to this distributed key value store example, if you want to write an operator for your distributed key value store, the first thing you would do is you come up with a YAML structure defining the configuration, how to run this key value store. okay? Maybe it contains, I want to have 3 instances and replication factor of the data should be 2, and I'm going to use this sharding algorithm or things like that, like whatever you need to configure your application. And then the user creates a custom resource with this configuration. And then you have an agent, an operator sitting in the Kubernetes cluster, listening and watching for this, your own type of custom resource, okay? And as soon as the user stores this custom resource, the operator will get an edit event because a new custom resource of this kind is added. And then the operator can read the configuration from it and start setting up your application. For example, first creating a deployment, and then when the deployment is created, starting to list and watch pods in this deployment. And when the pods change their status from container creating to running, then it might call some interfaces to configure them. If a pod is deleted and a new one is started, it might do something like that, okay? But initially, everything is triggered from this custom resource, and if the user wants to change anything, the user just edits the custom resource, saves it, then you get a modified event, see that something in the custom resource has changed, and reconfigure your key value store accordingly. So in the rest of the demo, what I want to do is I want to change the list and watch operation that we have and make it list and watch this type of custom resource that we see here. Actually, how do we announce that we have this custom resource in Kubernetes? What we need is a custom resource definition. And this is only about the metadata, okay? We tell Kubernetes we have a custom resource, we have a new group called Instana.com, a new version called v1 alpha 1, we define a new kind called demo, and this has nothing to do with defining what YAML we have in the spec, right? It's only about the metadata to let Kubernetes know that this new kind of custom resource exists. And now we can apply this custom resource definition, and now this custom resource type is known to Kubernetes, and now I can simply store the custom resource, okay? So, next step is, of course, we modify our example to list and watch this type of custom resource. There is a little bit of boilerplate code for deserializing the YAML into Java objects. So I have a little archive here, cr.tar.g. So it basically contains this CR package, okay? If you look into it, it created this package here, and demo resource is basically a Java model for our custom resource that I just showed you. So let's look at the custom resource again first. So basically, I mean, what the library, the Fabricate Kubernetes client uses is Jackson. Maybe many of you have heard of Jackson because it's always also often used with REST services and something. And it's basically a library where you have Java objects, you annotate them with Jackson annotations, and then Jackson can deserialize JSON or YAML into your Java object, okay? And so what we want to do, we write a Java object model where this YAML that we see here can be deserialized into. And if we look at it, we have something like the header with metadata and then the name in the metadata, and as soon as we store it, it gets a resource version and stuff like that. And this is the same for all custom, for not even for all custom resources, for all resources in Kubernetes. And so fortunately, we don't need to model it explicitly. So it's enough to just extend this custom resource base class, and there we inherit all the information that's the same for all resources in Kubernetes, like metadata name and metadata resource version, right? And this leaves us with a spec down here, which is basically application specific. And so I modeled the spec here as a Java class. If you look into this, let's make it a bit larger. It has just one property. I have this JSON annotation, Jackson annotation that it's called demo.properties in my YAML code, and the value is just a set of strings, okay? Just a simple example model. Of course, you could do whatever complex model you need to describe your applications here, right? And then there is a little bit of boilerplate, unfortunately. You need a list object, which is used for the result of list operations, but it doesn't need to do anything. You just extend custom resource list and that's it. And you need a doneable object that's used, I don't know, for whatever. It doesn't need to do anything. You just extend custom resource doneable and that's it. So that's unfortunately a little bit of boilerplate that you need. And then you have the object model for your new custom resource. And now let's get back to our client producer, where we produce the default client, and say we produce a singleton make custom resource client. And we take the default client as parameter here. So obviously the return type void is wrong. We want to return the client here, but I will do this as the last step because then IntelliJ can generate the return type for me, so I don't need to type it. Good. So what are the steps required here? First, we need to tell the library about our new class so that it can use it in deserialization. So this is Kubernetes deserializer register custom kind. And we tell it whenever you see something with API version instana.com v1 alpha 1 of kind demo, please deserialize these into the demo resource class. Okay? Then the library can, when it finds this YAML, deserialize it into this Java class that I just showed you. And then creating the actually client is the two-step operation. First, you load the custom resource definition, and then you use the custom resource definition to create a client object from it. So the first thing we need is custom resource definition. Let's call it CRD. And this is, again, a built-in thing, custom resource definition. So we can use our default client, say custom resource definitions list. And this is the same as we had before with pods list. It just gives us a list of custom resource definitions. And again, with get items, we can turn it into a Java list of custom resource definitions. And now we need to grab the one that we are interested in. There are, of course, many ways how to do this. I'm going to use Java 8 here and say stream and filter. And I know I called my custom resource definition demos instana.com. So I'm just going to filter the one where get metadata, get name returns demos instana.com. And I know it is there, okay? I just applied it in this talk live on stage, so I think we don't need to care about if it's not there or something. So I'm just going to say find any or else throw a new runtime exception. And I'm optimistic this will not happen. Good. And now that we have the custom resource definition, we can return a custom resources client, and we give it the custom resource definition as parameter, and then it needs all the class files that I just showed you, okay? The actual resource class, the actual list class for this result of list operations, and this doneable class, okay? And now it is red because the return type is not correct. So let's hit Alt and Enter to have IntelliJ fix it. And this is a little bit, I think the Fabricate Kubernetes client is actually quite a good library. The API is pretty good except for this little thing. First of all, the type is actually called mixed operation, which I think is a weird name for a client. And then it has too many generic parameters. So if I need to copy it now, it's that big. I don't know. Fortunately, IntelliJ can generate this, and you only need to use it once, and then you can ignore it. And the rest of the API is actually pretty good. So I hope this one thing doesn't make you think this is something bad or anything. Okay? So I just copied it, and then we can go back to our watcher, say inject again, paste it there, and call it CR client. Okay? And what we are going to do now, we modify the code that it no longer uses the default client to list and watch pods, but uses the custom resource client to list and watch custom resources. So replace the default client with our CR client, remove the pods, and then we have a list. And of course, this returns a list of our demo resource classes. And if we want to print it, we replace the type here. And actually, in this demo resource class, I implemented a nice toString method. So I can just print it without having to print the individual things here. So I can just put it here and remove this down here, and then we can print it with my new nice toString method. Okay, and the same change is down here. So it's just a custom resource client, remove the pods, and now we watch. And obviously we then have as parameter a watcher of demo resources, and then we receive the event and print the resource and remove the stuff down here. So if that was a little bit fast, so basically the message is the code is the same, okay? You just replace the client and of course then replace the type because you're no longer dealing with pods but with demo resources, but there's no like structural difference or anything how you deal with that. It's just, it works the same way as before, just with a new client and a new type, right? Okay, let's run it and see what it does. So this is again the same command to call Maven clean package to create our executable jar file, and then create a Docker image out of the executable jar, and then call kind load to load the Docker image into the kind cluster. The difference is this time I used another version. I call it version 2. So let's wait a second until it's copied into the kind cluster. Yeah, now it's there. And now what I'm going to do, I'm going to update my operator deployment from version 1 to version 2. So kubectl deployment, edit, operator example. Oh, no, not deployment edit. It's edit deployment, right? Like this. So let's check where the version is. It's here. So we currently have version 1 here. I'm replacing this with version 2. Save it, and now if we say kubectl get pods, we will see that Kubernetes is already doing something. It terminates my previous version and started a new version. Okay, so let's look at the logs, kubectl logs of this new operator example pod, and it works. We see an edit event for our custom resource with name hello world. It also has a resource version now because every resource in Kubernetes has this. And this is our nice toString method gives us the contents of this spec, which is just a list of strings ABC. And what we can do now, we can like simulate that this configuration changes. We can just say kubectl edit demo hello world, right? And then we say we add a D and an E down here. And as soon as we save it, we get a modified event. And our new demo resource class contains now this list A, B, C, D, E, right? And that's actually cool. I mean, I think although that's not much code, it's basically all you need to write your own operator, because what you can do now, you can come up with your own like YAML structure for configuring your application. You can start listing and watching for this custom resource that you created. Of course, maybe using a resource cache so that you can ignore old resource versions, right? And then as soon as you receive something new, like an edit event for a new distributed key value store configuration, you can do whatever you need to do in your business logic. For example, you could now use the default client and say deployments create, and then this will create a new deployment. Of course, the deployment is parameter here, but then you have a deployment, I think deployment builder. Deployment builder, right? And then you can use some setters here and eventually call build. And then it will create a deployment for you. And then you can, like with the same code that I showed you previously, start watching for pods in that deployment so that you get notified when the pods change from container created to running. And then you know all the individual pods are running. And then maybe like you can grab their IP addresses from the resource for a pod also has the IP addresses, and then you can call some configuration interfaces or whatever you need to do for application specific tasks to configure them and make them work correctly. Okay, so this is basically all I wanted to show in this demo. I think it's pretty complete because it's all you need to actually write your operator. I left out a few things that you don't need, but that are kind of conventions like that many people do. For example, if you create a resource like the deployment here, it's kind of a convention that you use the custom resource as an owner reference. So every resource in Kubernetes has an owner reference, and if you use it as an owner reference, Kubernetes will figure out that you created this resource because of this custom resource, and that helps with cleaning up. Or there's also the convention, I showed you the custom resource has a spec field. Many custom resources also have a status field, which is kind of where the operator, whenever the operator creates a resource, it leaves a small line there, a small message, so that you can see what it actually did. But all these things are just, you don't need them. It's just conventions, and most things do it. And I think a few of Red Hat's tooling also assume it's there. But yeah, it's not necessary to actually implement your functionality. So thank you very much for listening. So I hope what came across that you don't need to learn Go to run to implement operators. That has been necessary maybe 4 months ago, but now you have the tools. You have everything you need to write your operator. It's not even very hard. You can do it in a few minutes once you are familiar with the API, and there's nothing to prevent you from going ahead and trying it. Thanks for listening.